Hello, today we are going to talk about even and odd functions and symmetry. So mainly we are going to see how we can determine whether a function is an even function or an odd function. So let's look at the definitions. So the function f is an even function if f of negative x equals f of x for all x in the domain of f. So in other words, if you replace x by negative x in the given function, and if you get the same function, f of x, then we can say that it is an even function. So the right side of the equation of an even function does not change if x is replaced with negative x. The function f is an odd function if f of negative x equals negative f of x for all x in the domain of f. So in the given function, if you replace x by negative x, if you get the opposite of the function, then you can say that it is an odd function. So note that every term on the right side of the equation of an odd function changes its sign. So let's look at some examples. Consider the function f of x equals 2x to the 4 minus x squared plus 1. We need to determine whether this function is even or odd or neither algebraically. So we have to use the definition f of negative x equals f of x. So if f of negative x equals f of x, then the function is an even function. So in the given function, replace x by negative x, 2 times negative x to the 4 minus negative x, the whole quantity squared plus 1. And you can see that this is like 4 factors of negative x. That will become x to the 4. So 2x to the 4 minus negative x, the whole quantity squared is positive x squared. So keep that negative sign. So we have positive x squared, then plus 1. And you can see that this is same as the given function. So we can conclude that this is an even function. Let's look at another example. Consider the function f of x equals x to the 5th minus x cubed. So we need to determine whether this function is an even function or an odd function or neither algebraically. So replace x by negative x. Negative x to the 5th minus negative x to the 3rd. So negative x to the 5th is like 5 factors of negative x. That makes negative x to the 5th, then minus negative x, the whole quantity cubed. So 3 factors of negative x, right? So it is negative x cubed. So we'll get negative x to the 5th plus x to the 3rd. So you can see that all the terms change the sign, or when you compare this function with the given function, you can see that this is like the opposite of the given function, negative f of x. So we can conclude that this is an odd function. Let's look at one more example. We have given g of x equals x to the 5th minus x squared. So again, we need to find out whether this function is an even function or an odd function or neither. So replace x by negative x. Negative x, the whole quantity to the 5th power minus negative x, the whole quantity squared. So we know that this is like 5 factors of negative x. So that will give you negative x to the 5th and minus, this is negative x, the whole quantity squared, that is like x squared. So negative x to the 5th minus x squared. So when you compare this function with the original function, you can see that only one of the terms changed the sign and x squared has the same sign. So this is not same as the original function or not same as the opposite of the function. So we can conclude that this function is neither odd nor even. So it is like neither. Now let's look at the graph of this odd functions and the even functions. So consider the function f of x equals x squared minus 4. So you can see that this is an even function because when we replace x by negative x, we'll get the same function. And when you look at the graph, you can see that the graph is symmetric with respect to the y-axis. So the graph of an even function in which f of negative x equals f of x is symmetric with respect to the y-axis. And consider another function, f of x equals x cubed. So when you replace x by negative x, you can see that negative x, the whole quantity cubed, that is negative x cubed. You will get the opposite of the function. So it's an odd function. So the graph of the odd function is always symmetric about the origin. You can see from the graph, it is symmetric about the origin.